This figure presents a conceptual diagram of a cognitive radio engine operating on a software-defined radio, SDR, platform. Let's break down each component and explain its function in detail. Cognitive radio engine. This is the upper part of the diagram enclosed in a dashed box. The cognitive radio engine is responsible for making intelligent decisions about radio operation based on the current environment and available resources. It consists of 3 main inputs and 1 output. Environmental information. This input provides data about the current state of the radio environment, such as signal strength, interference levels, and spectrum availability. This information helps the cognitive engine to understand the external conditions in which it is operating. Available radio functions. This input includes information about the various radio functions that can be performed by the software-defined radio platform. These functions could include modulation schemes, power levels, frequency bands, and other configurable parameters. Performance metrics. This input provides data on the performance of the radio system, including metrics like throughput, latency, error rates, and energy consumption. These metrics are crucial for the cognitive engine to evaluate the effectiveness of different radio configurations and make adjustments to optimize performance. The central component of the cognitive radio engine is the cognitive decision-making module. This module processes the inputs from the environment, available functions, and performance metrics to make decisions about the best radio configuration. The output of this module is the final radio design and configuration, which dictates how the software-defined radio platform should be set up and operated. Software-defined radio, SDR, platform. The lower part of the diagram is the SDR platform, which implements the configurations decided by the cognitive radio engine. This platform consists of several components. Baseband processing. This section includes the core processing elements that handle the baseband signal processing tasks. It comprises 2 main parts. Microprocessor, a general-purpose processor that runs the software controlling the radio functions. Digital logic, specialized hardware for performing high-speed digital signal processing tasks. A/D and D/A converters. These components convert signals between the analog and digital domains. The analog to digital converter, A/D, converts incoming analog signals from the RF front end into digital signals for processing, while the digital to analog converter, D/A, converts processed digital signals back into analog form for transmission. RF front end. This is the radio frequency front end, responsible for handling the actual transmission and reception of radio signals. It includes components like antennas, amplifiers, filters, and mixers that operate at radio frequencies. Interaction between cognitive engine and SDR platform. The cognitive radio engine communicates with the SDR platform to implement the final radio design and configuration. The decisions made by the cognitive engine are executed by the SDR platform, adjusting its parameters and operations to optimize performance based on the current environment and available resources. In summary, this figure illustrates how a cognitive radio engine, which makes intelligent decisions based on environmental information, available functions, and performance metrics, works in conjunction with a software-defined radio platform to dynamically configure and optimize radio operations.